All right, so finishing up, we're going to do number 3, 4, and 5. I feel like it's easier just to have my calculator there for you to see when I push buttons and things like that. So let's start with number 3. I'm going to ask you to see if you can do 4 by yourself, and then we'll do 5 together. All right, so the path of an arrow shot in the air can be modeled by this function. Okay, and whenever we're given an equation, we're going to want to graph it in our graphing calculator. They tell us that y is height in feet and x is seconds after it's been released. And then we're going to try and find these, or answer these 4 questions. Okay, so first thing we're going to want to do is graph it. So hopefully I have this set up so you can see it okay, and we're going to put that in. So just remember, when you're graphing, just so that we're all on the same page, let's clear this out. So if you ever need to get out of your graphing, you just do second mode does quit. Okay, and we're going to do second plus, that does the memory, and we'll do 7, 1, 2. So 7, 1, 2, so that we're all on the same page. Okay, now when you go to y equals, it should be empty. There shouldn't be anything in there for you. And we're going to put in our equation. So what form is this equation? And this is vertex form. We don't need to switch it into a different form. We can plug it in just how it is now. So we'll do negative. Make sure we do negative instead of subtraction. So if we have a leading negative, it's got to be a negative, not a minus. Okay, so we'll do -3 parenthesis x. Again, this is our variable button, the xt theta n. That's our variable button. -4 close parenthesis square, and then plus 142. And we'll push graph, and you'll see that we can't see very much of it at all. Okay, and the reason why is this is vertex form, and this is our vertex. So without doing any work, we could just say our vertex is 4, 142. Okay, so that means our y value for our vertex is 142, which means our graph needs to be, our window needs to be a lot higher. So we'll click on window, and we'll scroll down to our y max, and we'll maybe do something like, I don't know, I'm just going to do 200. Okay, and we'll graph that, and we can see that parabola. But you notice our x value, our x-intercept I mean, is not on there. So let's change our window again. We're going to need to change our x max. It's at 10, maybe we'll change it to 15. Okay. One other thing we're going to change, since there's not, like our x-intercept is so low on our screen, when we start calculating things, you know how it gives you instructions, it's going to be hard to see it. So let's change our y-min to maybe, let's see, maybe our y-min, again, click window and then scroll down to y-min. Let's maybe do -80. I don't know, that sounds good to me. Okay, now when you're trying to calculate these things, you'll be able to see that still. All right, okay, now we're going to answer these questions. All right, so what is the maximum height the arrow reaches? So again, since it's in vertex form and we can easily find our vertex, we don't really need to do the calculate here on your calculator, but we'll do it just for good practice. So what is the maximum height the right arrow reaches? Well, that's your y value for your vertex. So we're going to need to find our vertex. And again, I already wrote that down, but we'll do it just so that we can practice. Okay, since it's a maximum, that's where we'll find our vertex. It's a maximum, and it says left bound, so it's already, for mine, it's already left of my vertex. And then I need to use my cursor to get to the right side, push enter, and then my guess is right there, and it tells me it's 4, 142. Okay, and that's what we wrote down here, and we can also see that in our equation. So if we're trying to find the maximum height, again, height is your y. It tells us y is height in our problem. So for the maximum height here is going to be the maximum, will be the y value for your vertex, which is 142 feet. Okay. After how many seconds does it reach that height? So this should probably say maximum height. So that would be 4 seconds. Number 3, how high will the arrow be after 6 seconds and at 8 seconds? So again, if we're trying to find a specific point, like I guess a specific or random, I don't know, it's not like one of our key features, I guess what I'm trying to say, is again, we'll go to second trace and we'll do value. And this is where you'd plug in what x is, or for this one, x is time, so we'll do 6. That's 130 feet. And then at 8, since it's already set up that, you can just push 8 now, and it's 94 feet. Okay. And then last but not least, at about what time will the arrow land on the ground? So what they're asking here is, what is the x-intercept? Okay. This is like your y value of your vertex. This is your x value of your vertex. And this is kind of like a random point, right? So if we want to find our x-intercept, remember we go to second trace and we do 0. 0 is our x-intercepts. And we don't really want the one over here because that has negative time. Time starts at 0. We always start at time equals 0. We never really look at what's in front of that. So we're going to want to find our left bound of this one, so that's left of it. And then over there, that's your right of it. And then your guess. And here I end up getting 10.88 seconds. All right, just round to the hundredths place, if you would. All right, so that's that. If you would, give 4 a try by yourself. Pause your video and do this problem, see what you can get done. Just remember that when we're using t's here, you're still going to use x's on your graphing calculator. Okay? All right, so pause and give that a try. All right, so I'm just going to go to y equals. I'm going to clear that out and put in my new equation. So it is negative, again, we use negative, not subtraction, negative 4.9 x squared plus 19.6 x plus 58.8. Okay, and hopefully I put that in all right. We'll push graph and we'll see what it looks like. Okay, so it looks like our window that we had before, looks like that would be okay. That'd be sufficient. We won't need to change our window. Okay, and we're going to answer these questions. So what is the starting height of the softball? So if it's like initial height or something like that, it's always going to be they're looking for your y-intercept. And again, if we want to find our y-intercept, well, since it's in standard form, this is our y-intercept, so we could just easily go and say it's 58.8. What are we doing? Feet? Time? No. Height. Height. I don't know if it says feet or not. We're just going to assume that it's feet. All right? So you can just do it that way if you wanted to. Since it's in standard form, you can. Or we can calculate it, and the way we did that is we did second trace, and we do value, and we would realize that for the y-intercept, or for our initial value, or initial time, would put 0. So when time equals 0, the height is 58.8. Okay. All right, and then next it says, what is the maximum height the ball reaches? And then next it asks, how long does it take to reach that maximum height? So those are both the x value for your vertex and the y value for your vertex. So we're going to want to find our vertex. So to do that, again, what we do, looking at this is a maximum. So we're going to go second trace, and we'll choose maximum. It's number 4, so I'm just going to push 4. left bound, looks like I'm something that's already left of it, and then I need to go to the right side. Enter, and then my guess. So my vertex is 2,78.4. So what is the maximum height the ball reaches? Well, y is your height. So they're asking here would be 78.4. We'll do feet. And how long does it take? Well, x is our time. If we're ever given time, x will always be time. Okay, so the time was 2 seconds. All right, number 3, at what time will the ball hit the ground? So that's our x-intercept that we're going to try to find. That's where we do zeros. So we'll do second calc. We'll do 0. And we'll do our left bound, right bound. Again, the left side is before time started, so we don't need to worry about that one. And we'll do left of it. Right, enter, and guess, enter. Okay, so we end up getting time is 6 seconds. Right? How high is the ball after 2 seconds and 5 seconds? So that's kind of the same thing we did to find our y-intercept, as we go to second trace and we do a value, and we'll just plug in our times that we want. 2, which we already did, was our vertex. 78.4 feet, and at 5, so I'll just push 5, enter, and it gives me 34.3 feet. All right, so I'm hoping this is helping you. I hope this is making sense. Feel free to stop in or shoot me an email if you need to. Last but not least is intersection. So 2 water fountains are modeled by 2 quadratic functions, and those are those 2. Okay, we're going to want to graph those, and then we're going to find all points of intersection between the 2. So first thing we're going to want to do is graph those 2 equations. Just because I have some practice doing this, I would say let's go back to our change our window, or an easier way to do that maybe is just to do zoom and go to standard, which is 6. So I'll just push 6, and it will change me back to a -10 to 10 and -10 to 10. And this will help when we change these, or put these equations in. So we'll clear these out, and we'll plug in our 2 equations. So we have y equals, again, negative. Use negatives, not subtractions, for the leading term. So negative x squared plus x plus 6 is one of our equations. And you can go down, or you can push enter to get to the next one. We'll do negative x squared plus 6x minus 5. And I'll push graph. And it looks pretty good. We can see these 2 graphs, and they do intersect at one spot. Okay, they don't intersect anywhere else. So we just need to find that one. All right, and if you remember how to do that, we go back to second trace, and then we're going to do 5, which is intersect. It says first curve, so it's already on one of them. Just push enter. Second curve, it automatically moves to the next one, so you can push enter, and then your guess. So I'm going to use my cursor to be somewhere near where they intersect, and then it gives me my intersection. So this would be 2.2, 3.36 would be our intersection. All right, well, if you have any questions on your homework, let me know. I'd love to help you out. All right, we'll see ya.